Welcome back to the course, Deep Learning using Matlab. In the previous lecture, we have learned about neural network, and now we are ready to learn deep learning. Deep learning is an extension of neural network. It is a type of machine learning that employs multiple layers. That means deep neural network is a neural network that contains two or more networks. This is a model of deep neural network. The training data train the deep neural network using learning rules. Once the network is trained, we provide input data and the network generates the output. You may think it's a very simple thing. What makes it so attractive? Okay, a historical fact may surprise you. It took 30 years to add another layer to hidden layer. Yes, 30 years. So what took it so long? It's the learning rule. No efficient way was invented to train hidden layer until 1986. Backpropagation algorithm was introduced in 1986, and finally the problem of training multiple layer neural network was solved. However, its performance on practical problem did not meet expectation. As neural network has very simple architecture, there was very limited scope of improvement. That is why eventually researchers stopped working with deep neural network and it remained forgotten till mid-20s. But current technologies in deep learning have outperformed other machine learning techniques as well as other neural networks. So the learning rule, which took 30 years for multi-layer neural network to solve problems of single neural network, and performance enhancement took 20 more years. So deep neural network took 50 years to reach to this current level. Deep learning is consisted of multiple single technologies. Improvement of these technologies eventually developed deep learning. First impediment of deep learning was training multiple layers, which was solved by backpropagation algorithm. Second problem with deep learning was poor performance. The reason of poor performance is improper training. The reason of improper training are vanishing gradient, overfitting, and computational load. Gradient is similar to delta or backpropagation algorithm. When output errors fail to reach further nodes, we call it vanishing gradient. In backpropagation algorithm, the errors are passed to hidden layers to train the network. If the error cannot reach the hidden layer, weights cannot be adjusted. That means hidden layer cannot be trained. There is no point of training hidden layers if they cannot be trained. This problem can be solved using rectified linear unit function as activation function. This figure represents rectified linear unit function, in short, ReLU function. The ReLU function gives us maximum value between 0 and the given input. We will need the derivative of ReLU function as well. This is the derivative of ReLU function. Deep neural network is vulnerable to overfitting because the model becomes more complicated as it includes more hidden layers. We already know that complicated models are vulnerable to overfitting. The solution to this problem is dropout. Dropout means training some of the randomly selected nodes rather than entire network. For example, first, these will be trained and rest of the nodes will be set to 0. In next training phase, other nodes will be selected for training and rest of the nodes will be set to 0. Now the question is, how many nodes will be dropped out in a training phase? Well, 50% dropout for hidden layers and 25% dropout for output layer produce acceptable result. Another effective method of preventing overfitting is regularization. It simplifies the architecture of network as much as possible. The last challenge of deep neural network is time required to complete the training. The number of weights increases geometrically with the number of hidden layers, and more layers require more training data. Large number of training data increases the training time. You may think training time is not a big deal. However, from a practical development perspective, it is a serious issue. If a deep neural network takes 5 days to train, you can modify the network only 6 times in a month. To complete the training process faster, we can use high-performance hardware such as GPU instead of CPU. The training algorithm also plays an important role here, such as using batch normalization algorithm can enhance the performance. So, we have familiarized ourselves with the challenges of deep neural network. Let's face the challenge and implement a deep neural network which will be able to recognize digits. First of all, we need to design the architecture of deep neural network. These are the input nodes, these are nodes of hidden layers, and these are the output nodes. Let's connect the nodes and complete the architecture of our deep neural network. I'm using an online drawing tool to draw this network. This is the complete architecture of our deep neural network. Now the question is, how many nodes are there in input layers and hidden layers? The number of nodes of input layer depends on input data. Our input data are digits. We will train the deep neural network to recognize digits from 1 to 5. To make the concept of input layer crystal clear, let's start with an empty matrix. This matrix can contain 25 values. Now you can see the 25 values more clearly. Let's make it empty again. I'm assigning 0 to these positions and 1 to rest of the positions. Now the matrix is no longer empty. Have you noticed one thing? Isn't it a binary image where 0 represents black and 1 represents white? Let's look closely. Can you see now? It is an image of 1 and it has 25 pixels. Similarly, we have 2, 3, 4, 5. Each of these has 25 pixels. As each of the input data has 25 pixels, we have to take 25 input nodes. Is it clear now? I'm pretty sure you have understood how to choose the number of input nodes. Now let's talk about output nodes. What we will have at the output? We will have 5 different values which represent 5 different digits. That means we will have 5 outputs. So we need 5 output nodes. Very simple, isn't it? I'm taking 20 nodes in each of the hidden layers. Why 20 nodes? Well, this is your homework. Let's assign the weight matrices. From input layer to first hidden layer, the weight matrices are W1. From first hidden layer to second hidden layer, the weight matrices are W2. From second hidden layer to third hidden layer, the weight matrices are W3. And from third hidden layer to output layer, the weight matrices are W4. We will train the network using backpropagation algorithm. The output we will get will be subtracted from correct output. The difference between output and correct output is error. This error will be passed back to hidden layers to adjust the weights of the nodes. The correct output is predefined because we're using supervised learning method. As our input is 5 into 5 matrices, let's take output as a 5 into 5 matrix as well. This is our correct output. Here, first row represents 1, second row represents 2, third row represents 3, fourth row represents 4, and fifth row represents 5. So, after training, if we put 1 as input data, the output will be this. Only the first value of the first row will have a value closer to 1. Rest of the rows will be 0 or close to 0. If we take 2 as input, the output will be this. Only the second row will have value 1 or closer to 1. Rest of the rows will be 0 or close to 0. So, I'm pretty sure that the concept has been clear. Let's start coding. Create a folder. Let's call it Deep Learning. Then create the first function. The name of the function is Deep Learning. You can use any name you want. However, as we are implementing this function for deep learning, so I prefer naming it Deep Learning. This function will take 4 weight matrices as input. It will take 1 image and 1 correct output as well as input, and it will return 4 weight matrices as output. After that, you can see alpha here. The value of alpha is 0.01. This alpha actually is the learning rate. By changing the value of alpha, we can control the speed of learning. As we have mentioned earlier that we're going to train this neural network to recognize digits, and there are 5 digits that we want it to recognize. As there is 5 digits, that is why we'll repeat this for loop for 5 times. At the beginning of the for loop, we are using a reshape function. Using this function, we are converting our image into a single column image. There are 25 rows in this column representing the pixel values of the input image. Notice carefully, the signal from the input nodes are actually the input image. This image is multiplied with weight matrices and getting inside the first hidden layer. We have used ReLU activation function as activation function of hidden layers. So the signal that is getting into the first hidden layer will be processed through ReLU activation function. Let's implement the ReLU activation function. Now the output of the first hidden layer is getting inside the second hidden layer as input signal, and this signal will be processed through ReLU activation function as well, and it is coming out as the output of the second hidden layer but getting in to the input as third hidden layer, and in the same way it is being processed through ReLU function and coming out as output signal of third hidden layer and getting in to the output nodes as the input signal. In the output node, we used softmax function. Let's implement the softmax function. The signal of the output nodes has been processed through softmax function in this last line. The difference between correct output and the final output is the error. But before calculating the error, we have to take the transpose of correct output, because we converted our image into a single column image. If we don't take the transpose of the correct output, then there will be matrix dimension mismatching and the program will throw an error. So I'm taking the transpose of the correct output and then calculating the error. After calculating the error, I'm assigning the error into a variable called delta to apply the delta rule. I think you have understood that this delta is the delta of backpropagation algorithm. Using this delta, I'm calculating the weights of the hidden layers that needs to be adjusted. And after getting the values that I need to change, I'm finally changing the values. So we have implemented the function. Using this function, we can train deep neural network. To train a deep neural network that can recognize digits, let's create another function named training network. In this network, we need the data that we will use to train the network. As I have mentioned earlier, that we're going to train a deep neural network that will recognize digits, so our input data are digits. But instead of taking the image of digits, we will create the digits using matrix. This matrix represents 1, this matrix represents 2, this one is for 3, this one is for 4, and this one is for 5. And after taking our data, this is the correct output. Now, I'm randomly generating the weights of the nodes of the hidden layer. These values will be passed to the deep learning function as weights. Finally, I'm calling the deep learning function inside a for loop. This for loop iterates for 10,000 times. That means using this for loop, I'm adjusting the weights of the hidden layers for 10,000 times and saving the network as deep neural network.mat. When we will run the program, it will train the deep neural network. You can see this is our deep neural network. Using this network, we can recognize digits. It's time to test our deep neural network. To do that, let's create a script named test deep learning. Load the deep neural network. Now let's take an input, actually which we will pass to the deep neural network to check how our network is performing. Let's start with 1. Converting the image into a single column matrix, then sending the signal through hidden layers. Like the previous one, we will take the output of the output node through softmax function. Let's run the script, and you can see our deep neural network has recognized the input as 1. That means it has given us the correct output. Let's test with another input. For example, I'm taking 2. I'm copying the 2 from other function and pasting it here. This matrix represents 2. Running the script, and you can see our deep neural network has recognized it as 2. Let's try with another one, copying 3 and pasting it here. Running the script, and you can see that It has recognized our input as 3, that is 100% correct output.